Hi everyone, and welcome to our science adventure today. Have you ever wondered why, when you kick a ball, it eventually stops? Or why you don't just slide all over the place when you walk? The answer lies with two super cool things: a famous scientist named Isaac Newton and a tricky force called friction. We all know Isaac Newton for his amazing ideas about how things move and why apples fall. But did you know that friction, this force that's all around us, actually helps us understand Newton's ideas even better? Today, we're going to explore this sticky secret. So, get ready to discover what friction is, how it helps us and sometimes makes things difficult, and how Sir Isaac Newton's brilliant mind helps us make sense of it all. Let's dive in. Let's start with friction. Imagine two surfaces, like your hand and the table. When you try to slide your hand across, what do you feel? A little resistance, right? That resistance is friction. Friction is a force that tries to stop things from sliding past each other. Even surfaces that look super smooth actually have tiny ups and downs. When these bumps catch against each other, they create friction. Walking. Friction between your shoes and the ground pushes you forward. Without it, like on ice, you'd slip. Brakes on a bike. Friction helps you slow down and stop. Now, let's bring in the genius, Sir Isaac Newton. Newton gave us three incredible rules, or laws of motion, that explain how everything moves in our universe. And guess what? Friction is a big part of how these laws work in the real world. Let's look at his first rule, Newton's first law, the law of inertia. It says, an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an outside force. So, if you roll a toy car across the floor, it eventually stops. Why doesn't it keep going forever, like the law says? Because friction is that outside force that slows it down and stops it. If there were no friction, that toy car would just roll and roll and roll. Next, Newton's second law, F-ma. This one is a bit like a math puzzle, but it's super important. It says, the more force you put on something, the faster it will speed up, accelerate. And the heavier something is, the harder it is to speed up. Imagine trying to push a heavy box. You push it, but it moves slowly. Why? Because you're fighting against friction. The real push that makes the box move faster is your push minus the friction push. So friction makes it harder to speed things up. Finally, Newton's third law, action and reaction. This law says, for every action, there is an equal and opposite reaction. This is where friction really shines. When you walk, your foot pushes backward on the ground. That's the action. What happens? The ground pushes forward on your foot with the same amount of force. That's the reaction. This forward push from the ground is friction, and it's what makes you move forward. So even though Newton didn't make a special law of friction, his amazing laws of motion help us understand exactly how friction works, why it exists, and how strong it is. His ideas are like the rule book for friction. Friction is super important in our lives. Sometimes we want lots of friction, like the rough soles on your shoes or the rubber on car tires to grip the road. Other times, we want to reduce friction, like when we put oil in a bike chain to make it run smoothly, or when we slide down a slippery slide. So the next time you walk, slide, or even just hold something, remember the amazing force of friction and how Isaac Newton's brilliant mind gave us the tools to understand this sticky secret of motion. What's your favorite example of friction in action? Let me know in the comments below. If you had fun learning about friction and Newton today, please give this video a thumbs up, subscribe to our channel for more exciting science, and hit that notification bell so you don't miss our next adventure. Thanks for watching, and I'll see you next time.